Okay, so today what we're going to talk about is the chain rule and how it impacts derivatives, how you use it with derivatives, and how when to know to use it. So you're going to learn how to use this in class probably, and you're going to be rusty at it. It takes a lot of practice. You have to be able to take a function that's given to you, like let's pretend it's something like this. Okay, cosine of 5x. Okay, you have to be able to take a function that's given and really understand that there's an inside function and an outside function. Because what you're trying to do is, if you ever notice that it's something that's a little more complicated than you're used to seeing, like well, cosine x, for instance. This looks like cosine x, but it's not just an x back here. It is a 5x. So the thing that complicates the problem is usually the innermost function. So the thing that's been stuck inside of another function is your g of x a lot of times. So with a problem like this, you really want to be able to break it down and say, oh man, that 5x is in the spot of x, and therefore you need to recognize that g is 5x. And it has been stuck inside of some other function. Now, in this case, the function that it's been stuck inside of or substituted into, that would be the cosine of x. So it's like there was this cosine function, and then the x was replaced with a 5x. So you really want to be able to understand what's been stuck inside of what. And once you do, you just need to take notes out to the side of what are the derivatives of each of these things, okay? So for instance, the derivative of g of x above is just a 5, and the derivative of cosine is just negative sine. Now, when you actually go to plug into this function right here, unfortunately you don't just get to slap all this stuff together. You really kind of have to think through, what just happened here. So when I read what the chain rule is supposed to be, so if I was asked to take the derivative of h, or the derivative of this side, I need to break into this formula up here. And this formula is telling me to first do f prime of g of x. Well, if I look down my list here, I have an f prime, but I did f prime of x. I didn't do f prime of g of x. So what I need to do is right under this, I'm going to do a quick note and actually find f prime of g of x. Now, what does that mean? It means that in the place of x, I need to plug in whatever the g function was, okay? So I'm going to recopy the negative sign, but instead of x, g of x was 5x. So I'm going to stick this into this function. So you should know how to compose functions already. So this is now going to be the first part of this formula, negative sine of 5x. And then it says I'm supposed to do times the g prime of x. Well, g prime of x I already did out to the side, and that was just a 5. So this is your derivative. This is your function. I'm going to make it pretty by moving the 5 to the front as a coefficient, just because it looks better that way. But that would be how this works. So let's try this again with something that's maybe not trig. I'm going to do the exact same stuff. Erase, erase, erase. Okay, so maybe you see like h of x is, I don't know, how about like x squared minus 1 cubed. Okay, so we see something like this, and if you didn't know better, you might just multiply it all out. And let me tell you something, that's actually fine. You can do that. It's just going to take you a whole lot longer. But if you notice that we have a function that's been stuck inside of another one, and if you can identify that, oh man, this thing that's inside the parentheses is probably the function that was put inside, so that would be my g of x, then all you have to do is figure out what was this stuck inside? Like, what could this have been if all this junk wasn't there? Well, I see parentheses and a cubed. And what that tells me is that the function, the outside function that it was probably stuck into, is just an x cubed. So somebody took an x cubed and replaced the x with all this mess on the inside. This is the hardest part for a lot of people, is figuring out inside outside. Once you do that, we take our notes to the side. The g prime would just be a 2x, right? and then the f prime, the derivative of f, would be 3x squared. So now that I have all this, I'm going to try to find the derivative of h, so I'm going to run into this formula here. Now, remember, I start with f prime of g of x. So underneath here, I'm going to go ahead and figure out what that means. Okay, well, f prime is this, but instead of an x, I'm supposed to plug in the g of x. So I recopy the 3 and I recopy the squared, but in the place of x is going to be all of the g stuff. So it looks like that. Very weird. I took the entire g function listed above, plugged it in right there. So that is the first part of my derivative. And then behind it I need to do times a g prime of x. Well, my g prime of x is right here. I've already done that out to the side. I've taken my notes. And now you can just put together what you can put together. I would do the 2x times the 3 and then recopy the rest. There's no need to FOIL it out and do all that, so I would probably leave it right there. So now that I've done 2, where I have actually broken it down to every single step and all the notes that you can take, let me show you how I do it, how my brain does it. And after you do a few of these, you will probably want to do it the same way my brain does it, because it's a lot easier and it's a lot quicker. But I wanted to show you with this formula why this is working. When I do a chain rule, my brain pretty much repeats the same thing, and that is, let me do something like this, 3x plus 2 to the 1/2. Okay, if I were to see this, I would immediately notice, oh, some junk inside the parentheses, and then it's raised to a weird power. So I would immediately notice that this was the inside function. And the way that my brain does it is since this is f prime of g of x, I just think to myself, okay, well, f is the outside function. So what's the outside function? So the outside is just something to the 1/2 power. So when I break into my derivative, my brain says, oh, okay, I'm going to do the derivative of the outside function. Well, that would just be bringing the 1/2 to the front and then reducing that power by 1. So in other words, it's like I'm ignoring everything in here and just pretending it was an x. And then I just take the derivative of something to the 1/2 power. So I did all that. Now, there's got to be something in these parentheses, right? Well, the something in these parentheses is just a recopy of what was already here. So if that's the junk that was in the parentheses, it's still the junk that's in the parentheses. Then out behind it, I do times the derivative of the inside. So this is all me doing what's the derivative of the outside, and now times the derivative of the inside. Well, the derivative of the inside is just a 3. So for me, instead of taking all the notes, and after you do a few, you'll be able to do this too, you just do it like this, and then put the 3 and the 1/2 together. And then we could write it like this. We could also remember a negative exponent means that that is all going to the denominator. So all these different ways to write the same thing. Okay, so all 3 of these are the answer. I would vote on that as the best answer. Okay, so I'm going to do another one with my quick shortcut way, and that'll be the end of this video. Hopefully this helped at least one person out there in YouTube land. And if not, I'm sorry I wasted 10 minutes of your life. Okay, so let's do one more. Maybe we're trying to take the derivative of the cosine of 3x squared minus x plus 2. Okay, something like this. And you know what? Let's change this to a sine, just to change it up a little bit. Okay, so I definitely notice there's complications here. I see sine, but there's no x behind it. And let me make this clear. If it had been sine x and then all this stuff behind it, this would not be a chain rule. If it had looked like this, we would be doing a product rule instead, because this would be one of the terms, this would be the second term. But when I look at this, all of this junk has taken the place of the x, okay? So because of that, it's got to be a chain rule, and I'm going to talk through it like I did a second ago. For me, it is derivative. Oh, my pen stopped working. No. There we go. Derivative of the outside function. Now, whatever's inside the parentheses would be the inside, okay? So derivative of the outside is sine. So what's the derivative of sine? It's cosine. And when I go to put something in here, I just recopy what I see above. Then out here, it's times the derivative of the inside. So the derivative of the inside is the derivative of this polynomial. So that would be a 6x minus 1 plus 0. Okay, so that is your chain rule. And there's, of course, it gets more complicated with double chain rules and maybe a chain and a product mixed together, and blah, but we'll cover those in a later video. So good luck trying some problems.